Welcome to JEE Previous Year's Electrostatics Paper Part II. In the first video we discussed about certain questions. Now we'll discuss about certain more questions of JEE 2015 and 14. 2016 we have covered there and partly 2015 only. You might consider कि 2015 में इतने क्वेश्चन कैसे हैं या 2014 में यूजुअली तो एक या दो क्वेश्चन होते हैं. But you must remember in 2015 and 14 there were 3-4 online papers and one of offline paper. तो इस तरह 5-6 पेपर होने की वजह से हर पेपर के एक दो क्वेश्चंस हैं. So I have taken again the selected questions. आइए. Now this is 2015 question. Electrical field exists in a region of space. Potential at the origin is taken to be 0. Find the potential at x is equal to 2 and y equal to 2. Now x equal to 2 and y equal to 2 should be, you should remember it is 2i plus 2j. Field is given, we want potential, so we remember the basic formula is equal to minus dv by dr. We try to find the formula. dv is minus dv and then we convert dr as dxi plus dyj. I dot I will be 1, I dot j is 0, so we simplify that, it comes out to 25 dx plus 30 dy. Now dx value is 2 and y is again 0 to 2. We get all these values confirmed and what we get is minus 110 volt. So you should see that D is the answer. This is one of the easier questions from 15. Now this is another question, 2015, one more set of online paper. It is given 2-point charges are inside the cavity of spherical shell. Charges near the surface of the cavity are opposite sides of the center of the shell. Sigma 1, sigma 2 are the inner surface and Q2 charge on it. Similarly, the charge and surface charge on the other. And this is the diagram given. Remember, this is the question of the Gauss law. So as per Gauss, since it is a spherical shell, that means within this region there is no electrical field. Within this region, I am showing you this is no electrical field. When there is no electrical field, there cannot be any charge. Here the charge plus minus gets cancelled. In fact, whatever charge, negative charge develops here, same will develop positive here. And if I make a complete loop, the net charge will again be 0. So inner charge will always be 0. Surface charge also be 0. Surface charge. Similarly, at the outer periphery, supposing at this point I want to check, so here also the charge would develop, but the net charge will remain 0 because positive, here you get negative, again you get positive here. So this positive and this negative here, they'll get cancelled. So let's see the options which were given to us. Sigma 1, 0, Q1, 0 and so on. These are the two options which are given to us. In fact, the question is not properly framed here. Sigma 1, he says the surface charge on the inner surface and Q1 the net charge on it. So what do they mean by surface charge? Actually, but still, for our purpose, we should know that there is no charge inside, no surface charge density also. Hence, the option 1 or A is correct in this case. So we proceed to next question. Again, this is the 2015 again electrostatics question. Disk is there. Radius B is 2A. A is the inner radius. This is A. This is 2A. There is a disk. Hollow disk you can say. It is having some charge. You have to find the electrical field at a distance of height h from its center. That means at this point you want. This is height h. So A is much larger, way somewhere very near to it. Now remember, this is again a question which is not based on the formula which you study in NCERT or usually in the boards, because this is the question talking of the electrical field due to a disk. In fact, electrical field due to ring also is not in any of the NCERT books or board books. But still, due to ring we study, but due to disk we rarely study in the boards. But for the competition we should know. Right now I'll write the formula and start. This is the options given to you. Now this is the formula. E is equal to sigma by 2 epsilon 1 minus x upon r square plus x, where x is the distance from the center. In this case x is h. Now we have got to understand, either we integrate it from A to 2A, or what I have done, I have taken the electrical field due to entire disk and then subtracted the electrical field due to this hollow region. So again I'll get the same answer. by using directly formula. I am just avoiding the integration. So at the first space we get E1 and E2. In the first case you should see that radius once is A and another is 4A. 4A square, 2A squared is 4A square, this is A square. I have to find E1 minus E2, I will subtract, and remember now this things comes to picture that H is much smaller than A. That means in this region only A will remain. In this region only 4A square will remain. That means root of 4A square will be 2A. So now we get the value E2 minus E1. We now at this point we put the condition H is much less than A, and this is what we get. So what we have to find, CH. H you leave. What is C? Sigma upon 2 pi epsilon naught A into 2A, that is sigma upon 4 pi epsilon naught. So the correct answer is C. Again, this is not the question we usually do in NCERT, so this is outside that syllabus, but we should understand that when we are sitting for the competitive exam, these questions we must know. Now we go to 2014 question. He has given the distance 5 millimeter in a capacitor, dielectric constant 2.2, and he has given the electrical field inside the dielectric is 3. You should know that even the electrical field outside is E, so within dielectric it is E upon K, where K is the dielectric constant. Here is the adversely, he has given you the electrical field inside dielectric, so outside field will be 2.2 times this. So first of all, electrical field outside the dielectric we try to find. This comes out to be 6.6 into 10 to the power 4. Now this is the electrical field, and we know the formula for electrical field also, sigma by epsilon naught. So sigma comes out to be E into epsilon naught. We place the values. Epsilon naught we know 8.85 10 to the minus 12. So my final calculation comes out to be 5.8 into 10 to the minus 7. It's more closer to A, so our option will be A in this case. This is a simple question, but in this case you should remember that 5 millimeter distance, which is over here, it's of no use. This is excess data. We need not to get panicky about this, and the answer is A. Next question again on 2014 is given electrical field 30x square. Similar question we had done previously also, 2 slides back. He wants the potential at the origin VOE and the at x equal to 2 here to find it out. Again we know the base formula is minus dV by dr. We try to find dV. EdR is 30x square. We have to integrate it because it's only I value, so we'll take only I. We integrate it, it comes out to 10x cube. Values from 0 to 2, we place the value, and what do we get is minus 80 volt. In fact, over here again you can see in 2014 they have asked the potential and the unit they have written is joules. It should be volt all here. So these are certain errors which can be made by any person, so we need not to bother, but my answer is minus 80 volts. So C is the answer. Now one more, again similar question in a one more set. Here he has given the electrical field in I and J. Value of E0 is given, and he says the flux on this field you have to find through a circular surface of radius 0.02 meter parallel to YZ plane. 0.02 meter radius in YZ plane. So we should remember now in the Gauss law we have studied the area is the vector. So we should know what is the direction of. So YZ plane means it is I direction. So as the surface is parallel to YZ plane, area is pi into 0.02 whole square in I direction, that is X direction. Now I make the area as I, 4 pi 10 to the minus 4 I. Now flux is E dot A. It is given already to E naught to me and A to me I have given, and I multiplied. I dot I is 1, I dot J is 0. You can see the value comes out to be 100 into 4 pi 10 to the minus 4. 4 pi is 3.14. We multiply, we get 0.1256. So he's saying the nearly answer will be A, 0.1256. So that's the answer is A. This is again a simple question. Now this is another question. It is based on some of the subjective questions. The dielectric constant varies in a parallel plate capacitor, and we have to find the net capacitance. This is a really good question, typical question, which is already being asked as subjective, but not in CBSE. So this is a slightly tedious question, and it requires a lot of calculation also, so we'll try to do that. Let's make a capacitor, what he's asking here. is area is A. This point, the permittivity is E1, this is E2. So I make a thin slab of dx thickness over here. D is total distance here. So at x distance from one end, dx thickness, I make this as a parallel plate capacitor. So this is the capacitor for which area remains same. This is the distance, and I can consider this lot many such parallel capacitors added in series. So in series it is 1 upon C added. So I try to find the capacitors of this differential plate. For that I have to find epsilon naught A by D. Basic thing is epsilon naught. To find the epsilon naught, the permittivity. So by unitary method I can say epsilon 1 is here, epsilon 2 is, so epsilon 1 to epsilon 2 changes in D distance. So changes epsilon 2 minus epsilon 1 by D per unit distance. So for x I get the value like this. Dielectric constant of dx is epsilon 1 plus epsilon 2 minus epsilon 1 into x by D, because D is total distance and x is this over here. So I simplify this. Now capacitance of this dx, epsilon naught A by D. Now there are a lot of such plates in series. In series net capacitance 1 by C. So I try to find the capacitance as 1 by C. So 1 by C is 1 upon differential DC. So I have to find 1 by C. So I integrate it. 1 by DC. This is DC only, differential capacitance. I invert it. It's D dx A by epsilon naught A by D. From 0 to D. From 0 to D, because my distance changes from 0 to D. At 0, the permittivity is epsilon 1. At D, permittivity is epsilon 2. I integrate it. It will get the value as log. So I change the limits, find the value. You can calculate this. This comes out to be ln E2 by E1. So this is more nearly from the D answer. Actually in the option they have given epsilon naught. So over here either they should write the permittivity varies from E1. It should be relative permittivity varies from E1 to E2. Because they have written permittivity, I have taken E1. Otherwise, if it would have been a relative permittivity, it would have been epsilon naught, epsilon 1, epsilon naught, epsilon 2. That's the only difference. So you can see D is the most appropriate answer for this question. So we find D as the answer. So with this is the answer. So this completes the 2014, 15 and 16 questions from 7-8 papers, all of electrostatics, so that you should know what is being asked. In my next video, we'll try to find the questions which are being asked in current electricity on this. Similarly, we start with the advanced course also. For such videos, you can subscribe to my channel on YouTube, and also any student who want to join my online course for NEET, AI, PMT, etc., you can contact me. My email ID is given. This is my course will include all the study materials and videos and tests and other assignments as well. You can join me. My email ID is given. Thanks for watching the video, and hope it has clarified your doubt that what is being asked you should know. Thank you.